Cool. Perfect. Hey, thanks everyone. Thanks for being here. I'm here today to talk about building Compose applications, Jetpack Compose apps that can be accessible for all of our users. So yeah, nice to meet you. My name's Joe Birch. I'm an Android engineer at a company called Buffer, and I'm over in the UK right now. It's very rainy, it's very cold, so yeah, would prefer to be in a much sunnier place, but doing this remote. So yeah, let's get started. So before I get started on Jetpack Compose and stuff, I want to take a step back from technology and from any kind of technical content. I think unintentionally, it's easy for us to become isolated from others around us. Life is busy, and it's easy for us to get caught up in our own things. So we can often forget or not even think about the things we are doing and how they might look for someone else. For example, maybe if you're at this conference in person or you go to an event, maybe how you get to that conference. If you were blind, maybe deaf, how would that have looked for you? How would you have safely found your way to the public transport station, cross that road safely, knowing that there was no traffic coming? Even what you did on that journey could look completely different. And while people manage to do these things, we may know that these things aren't always as simple as they might be for us. So being in this bubble, it may come as a surprise to some people to hear that 15% of the world's population has disability. That is equal to about 1 billion people. So whilst this is kind of vague, seeing as there are so many different kinds of disabilities, it's quite a high number. And as a lot of disabilities are often age-linked, this is a number that as the years go by is bound to rise in a linear fashion, unless we have some kind of medical breakthrough in the following years. And that statistic is validated by the fact that only 17% of people with their disabilities are actually born with them. So this is a pretty low number. So for example, in the case of the UK, 83% of the 11 million people in the UK with disabilities developed them after they were born. So it's far more common in this case to have some form of disability that you have taken on at some time in your life after you've been born. And that's something that really surprised me at first. And when it comes to these disabilities, a lot of things that we need to bear in mind have a lot of crossover. So for example, one thing that may help someone who be blind may also help someone who has a cognitive disability also. So with all that in mind, what can we do about this when building apps with Jetpack Compose? So we'll come on to the practical side of things shortly, but first we're going to take a look at how things are working under the hood. So the key concept when we come to accessibility in Jetpack Compose are semantics. We're going to be hearing a lot about semantics over the coming slides, so it's important to understand exactly what these are. So when working with the view-based UI on Android, our views are clearly defined. If you're an existing Android developer, you may have used the view-based UI toolkit. We have some rectangular space that a view occupies, along with the various properties that they hold. When it comes to composables, our UI is emitted into the UI hierarchy, and at that point, we rely on semantics for these services to be able to understand our UI. So when it comes to the use of composables to build apps of Jetpack Compose, composition provides a description for components within our user interface. These composables are then run to produce a representation of this user interface. We can view this representation as a tree-like structure that describes how our user interface is drawn. However, this isn't the only tree representation that exists. Alongside this tree is also a tree that represents the semantic meanings of our composables. These are two very different concepts. The composition tree, for example, the one on the left, describes how our UI is going to be composed, as in how it's going to be drawn on the screen. The semantics tree, on the other hand, for example, on the right-hand side, describes the semantic meaning of these composables, giving meaning to each component that is represented within our UI. But why does this matter? So when it comes to accessibility services and testing frameworks within Android, knowing how our composables are being drawn is not too useful for these. Accessibility services need to describe the components to users. Describing how the composable is being drawn is not going to provide enough information to aid the user of our apps. For testing frameworks, again, there will not be enough information to effectively be able to test our composables to a certain extent. Instead, These services need to know more specific details about these composables. This could be a textual value that is being displayed to the user, or some form of description that describes a visual component within our composable. This way, these services can look at the description of our composables and portray this effectively to the user, as well as providing a way for developers to perform assertions and interactions with specific components within tests. The good news is that in a lot of cases, semantic meaning will be automatically applied for us when we are using certain composables. For example, if we use a text composable to display some text to the user, this will be represented by the text semantic property. This text becomes how this composable is also described via semantics. This means that when a screen reader is focused on this composable, this description will be read to the user to describe the given composable. In a similar fashion, from the Compose testing framework, we can use this description to locate a given node within our composable tree. Once the node has been located using this description, we can then perform assertions and interactions on it. Without this description, it would reduce the usability of our app when accessibility features are enabled. It would also be difficult for us to locate these within the testing framework. So while some composables will populate these for you, in some cases, you will need to manually provide your own descriptions. So for example, in the case of visual composables such as the icon or image, if the visual representation of these adds information that aids the experience of our UI, the screen reader will provide these elements without that description. The same goes for custom composables or lower level drawing on the canvas. If you do not provide descriptions that will be used to populate the semantics tree, then the accessibility services will not be able to describe your apps to users. From a testing perspective, you also experience difficulty when trying to automate the testing of these components. For a lot of composables, as I mentioned, semantics will be automatically inferred from the composable definitions. So we have a composable with text, and TalkBack will be able to read that to the user. And the same goes for other things such as buttons that are disabled, checkboxes that are checked, and so on. However, in a lot of cases, there are composables that won't have sufficient semantics to describe elements to users, as well as there being opportunities to build on the default semantics so that we can provide an even better semantic experience for users who need those descriptions. And this is where we come in. As developers, these are the points which we can intervene to improve the accessibility of our composables. And this is what this talk is all about. So now that we have some understanding of how things are working under the hood, we can move on to learning about some of the approaches that we can take to make our composables accessible to users. We'll work through a collection of examples where accessibility can be hindered, allowing us to see how TalkBack operates, as well as how we can solve these issues when it comes to Compose. So the first thing I want to look at here are composable touch targets. So we need to ensure that any composables that could be interacted with have a big enough area that could be touched. So I'm sure we've all interacted with a UI component at some time that has a small touch area, or attempted to use our phone on a bumpy car journey. Having big enough touch targets helps to ensure that our components are interactable by the user at all times. When I first started looking into semantics, this was something I actually overlooked because it was something that we can control via compose modifiers and rather than through semantic modification. So let's take a look at this composable as an example. We have an icon and we have applied the click modifier so that we can listen for click events. We can see here though that the touch area only wraps the size of our icon, and our icon itself does not meet the minimum requirements to ensure that this composable is accessible. Clickable elements should have a width and height of at least 48 dp to ensure that they are accessible to the user. Without this, users may encounter friction when trying to trigger events within UI components. What we can do here is utilize sizing modifiers so that the clickable composable has a size that meets the minimum requirements for an interactable touch area. We can use minimum size modifiers or static size modifiers to adhere to this, depending on the content that you are displaying. We can also mix this with padding to increase the area of our composable. It's important to apply the padding between any size and clickable modifiers as to ensure that the padding is added to the size of the composable while still ensuring that the whole composable is clickable. With this in place, we can now see that our composable has an increased touch area, reducing the friction that users would encounter when trying to interact with our composable. So while this works, there are some ways in which this can be achieved with much less effort. which is by using some of the built-in things that Compose already offers. In the case of our icon, we actually have access to what is called an icon button composable. This composable takes a clip listener and a content composable. Being a button, this composable is designed for user interaction, meaning that by default, it will have the minimum required sizing for a touchable component. This means that we won't need to apply any sizing or padding, as the composable already has that configured and has the accessibility requirements in mind in its design. We can see here that this gives us the same result as we saw previously, except with reduced effort from our side. With that in mind, it's important to default to using predefined composables, especially from the material library, if what we need is already available in the system. To recap on these touch targets, we need to ensure that all composables that can be interacted with via touch events have a touchable area of at least 48 dp. And remember, you can use a mixture of sizing and padding modifiers to achieve this. While that is possible, though, lean into using existing implementations of composables where available, such as composables that are provided through the Compose material APIs, like we saw with the icon button. Another example of this icon and icon button combination is the use of a text button instead of a text composable. Sometimes in Android, we've created text views and made them clickable instead of using the text button, where the text button is designed for that exact scenario. So when possible, avoid sacrificing these minimum touch targets based off of the designs that are provided to you. In fact, this is actually a great opportunity for you to pass on feedback to designers and educate about accessibility requirements to your team. And if you are using material components that provide these requirements by default, be aware of any overriding of these touch targets and sizes, as if you start changing these, they'll actually break the accessibility requirements. So whether you're working on this or you're reviewing pull requests, that's something to be aware of. Cool. So when UI components are touched or navigated to when talkback is enabled, those click events won't be triggered right away. Instead, the composable will come into focus for the accessibility services. When this happens, some composables will rely on descriptions to have their meaning portrayed to users, and it is our responsibility to provide that meaning. So let's say we have this composable, an icon. This could also be an image that is loaded from a URL or a local resource, but no matter the source, it is a visual element. These composables will all require a content description argument to be provided to them. However, this is actually a nullable argument, so we could technically just pass null for this, right? Let's see how talkback behaves when this is set to null. Unfortunately, there isn't going to be any audio on this next video, but I'll describe it to you so you understand what's going on. So what happened here, we can see here is when settings is focused, settings will be read out, but nothing is communicated to the user when the icon is focused. And this is a problem because whilst there is an element focused, the user has no idea what that button will do. Looking at that button, we think maybe it closes it, maybe it deletes it, but there's no description there. And without this description, we could hinder the experience for the user. Instead, we can provide a content description to this argument. We'll grab a string from our resource that provides some kind of meaning to this visual element, such as close screen, and then talkback can properly communicate this to the user. So now with this talkback applied, talkback is able to portray this meaning of the visual element to the user. There's no guessing what this might be or frustration from missing context. We provided this description so talkback is able to effectively communicate this to the user. So we might also be working with composables that do not have this content description argument. In these cases, we can use the semantics modifier to manually set a content description for a composable. This will be useful in cases where you are doing some form of custom drawing, such as using the canvas, and you need to portray meaning for a visual element that is being composed within your UI. So when it comes to these content descriptions, you can use them to provide meaningful descriptions for your composables, allowing accessibility services to provide meaning to visual elements on the screen. And remember, it's okay to mark content descriptions as null if there is no need to provide meaning for a composable. This is usually when the composable is for decorative purposes only. So in a lot of cases, we are required to provide some form of value for a content description, even if it is just null. It's important not to default to just applying null to stop the compiler from complaining and telling ourselves that we would do this later. I'm sure many of us, and I am guilty of this also, is adding null as the content description argument in the Android view system, or using the suppress warnings lint check and avoiding it completely. So yeah, avoid passing null if you can provide a meaningful description for the user. Finally, remember that not everything will require content descriptions if they're there to add meaning, which some things such as dividers and so on don't need descriptions. So only add them if they are needed. Cool. So alongside content being described, there are further types of descriptions that we can provide in Jetpack Compose. For composables that are clickable, we can provide what is known as a click label. This is not visible within the UI or to the user, but if talkback is being used, then when a click action is communicated, the click label will be used to describe the purpose of that click action. So when implementing a clickable modifier in Jetpack Compose, we're likely going to see things that look like this. We have some composable that we want to enable click events for, so we apply the click modifier and then handle the click event for that composable. So when it comes to talkback, that component will be focused, but the user will not be communicated what that click action is for. So these cards will be focused, and the user will be told a click action, or there's a click action available, but the user has no idea what that click action is for. Is that a terminating action? Do I have to click it to find out? Is that click action going to delete my email? The user has no idea. They just know that they can interact with it in some way. What we can do here to improve this is to provide an on-click label, which will be used to communicate the purpose of the click action to the user. This takes a string, so we can provide this in the same way that we would for a content description. This will then be portrayed to the user when they are navigating through the cards. So now, when the user is navigating through the cards via talkback, talkback can clearly communicate what the click action is, allowing the user to really understand the purpose of that click action and what it will result in. And so here we are removing a massive amount of friction when it comes to the UX via talkback. So we can see here how we can use click labels to provide interaction descriptions to users for the composable that has the action available. Now, click action labels and content descriptions do serve a different purpose. Content descriptions describe the content, click labels describe the action. In a lot of cases, these will be read out together, so be sure that they complement one another and are not just repetitions of the same content. We also should rely on content descriptions to describe the action for content. So the click labels are there for a purpose and what the user relies on for action descriptions. So we should be using those labels to describe that. And the same goes for modification of other semantic values. If you're describing a click action, use the click label to do so, not any other semantic properties that you may come across and think may be useful. So talking of text semantics, this is a good segue into taking a look at what these are. So while click labels are used to describe the actions that can be performed through a click event, the text semantic allows us to control the text that is used to describe a composable. So let's take another example. We have a text composable that is displaying some text to a user. In a lot of situations, we won't want to apply any modifications. The text semantics, I think, is one of those things that is rarely going to be touched unless you really need it. However, with this specific example here, we have the example of the P/M. So a lot of people I've spoken to about this portray this differently depending on the context that it's in. So in this case, it depends what other UI there is, but this could mean per month, per meter, something else, anything that begins with P and M. However, talkback doesn't have the rest of the context of the screen to be able to work out what we mean here. In the example, what actually happens is that when talkback focuses on this, it's reading per meter. And what I meant in the context of this was per month. So maybe I'm showing a listing for a rental on an apartment. But there's no context here for talkback. So the abbreviation is wrong, and this could be confusing to the user. What we can actually do here, though, is we can make use of the text semantic property. So this is not what is used to describe a piece of content, but it's actually the property that the accessibility service will use as the representation of that content. So what we can do here is essentially provide a value that is used to override the semantics of our composable, meaning that this new text property will provide used by the accessibility service for the representation of this textual content. So visually, the user will still see this 60/PM, but when it's communicated via talkback, it will say £60 per month instead of £60 P/M. So what we are doing here is overriding the text semantic property for the accessibility services whilst also not modifying it from a visual perspective. So from this example, we can see that we can use text semantics to improve the represented text on screen that is composed. So we are essentially changing the spoken representation without modifying how it's represented within the UI. But because we have this text semantic, it's important to override it where applicable and not use other semantic properties to provide alternative values. So overriding the text semantic will replace the existing semantic value, so it will avoid any values being represented multiple times. For example, if you try and do this within a content description or a click action, again, you're going to end up with duplicated descriptions being read out. So if you need to change how a visual representation is represented, use the text semantic property. On that note, also, the text semantics are not something that we really should need to override often. While they can be used here to simplify textual content, as well as add clarity to it, it's not something that we should need to use regularly over and over again to override any composition. So, with the examples of these semantic values, we've been able to see how talkback will navigate through the different composables in our hierarchy. And you may be thinking, that seems like a lot of navigation. And this is where what is known as merging descendants comes in handy. But why exactly would we want to do this? So let's take a look at another example. The content here isn't relevant, but let's imagine we have a composable tree that is representative of the structure that we see on screen. We have a column that contains a row with 2 child composables along with another text composable. When it comes to talkback, we would see that every child in this composable is focused, meaning that the user needs to navigate through each of the focusable items on the screen. So we can see here with talkback, we're trying to navigate through a list of emails, and that navigation becomes a little tricky because we can see that talkback is navigating on every single item. So we want to remove this friction when using talkback so that we can utilize semantic merging to reduce the number of focusable elements within a composable. So when it comes to composable code, this is actually a very minimal change. When we can use semantic modifiers, in the example shown on screen, we can actually provide a flag, which is used to indicate whether we want to merge the descendants of this composable. So this will default to false, so you don't need to provide it. You don't need to provide a value for it if you're wanting to declare false. But you need to provide the true value to be able to merge the descendants of the composable. So when you do this, here we've merged the descendants, and now the whole column is being recognized as a single focusable item. Talkback will now read the title, data, and description as part of the representation of the composable in one go. This now means it's also much easier for the users to navigate through the list of emails, as the list is made up of single focus emails rather than each email having 3 focusable elements within it. Now, this will really depend on the content you're displaying. So if, for say, each of these emails had a massive paragraph for each of the descriptions, it wouldn't make sense for us to read the entire content out to the user, or they could skip the content focusing to the next item. So it's important to think about when you're using this and if it's applicable for the scenario. So we've seen here how we can use the merge descendants flag to compress multiple semantic values into a single representation. This not only helps to remove bloat from the semantics tree, but also makes our UI much easier to navigate through when using accessibility services. However, navigation should not be a sole reason as to why we merge descendants. It should strictly be done for when multiple descriptions are not required for the same area. If it makes logical sense for components to be traversed through and described on an individual basis, then they should be kept that way. So it's important to keep in mind the use case you're working with and if it makes sense. So alongside these semantics modifications, we can also provide a description which is used to describe state. So for components that have dynamic state that can be controlled by users, such as switches, checkboxes, and radio buttons, this allows us to add clarity to the state of a component and describe the state that is currently being represented, rather than relying on the visual representation of that. So let's take an example of this in the form of a toggleable component. We have a custom switch composable that could be toggled between on and off. And we can see here that this is being manipulated within the on value change modifier of the toggleable modifier. So when it comes to talkback communicating this, there's not going to be a lot of context. So it's not super clear to the user what the state of the switch currently relates to. So what talkback reads out here is essentially on, off. So while we can focus on the whole row again to hear the semantic description, it's not very clear to the user what is actually happening. If I have to then look at the switch, I have to look back at the label, and we're adding a little bit of friction for the user there. What we can do here is utilize the state description semantic to provide some meaning to the current value of the state. So here in my composable, I am now building a string representation based on the current value of the enabled flag, followed by assigning this to the state description semantic property. So with this in place, talkback will now be able to describe the state with much more clarity. So now instead of this just reading off, on, talkback will be able to read that string that we provided, which is actually represented by notifications enabled, notifications not enabled. So what we're doing here is overriding that default on or off communication and giving that state some context. So the talkback will say notifications enabled, and then if the user goes to the next item, it will say, we can say dark theme disabled, which just gives reduces the friction greatly when it comes to talkback. So from this example, we have seen that we can use state descriptions to add context to the current representation of state, allowing us to expand on a simple on-off status of a component, allowing our users to understand state quicker with much less friction. So with that said, state descriptions should only be used for what they are designed for, which is state descriptions. We shouldn't use these to instruct our user on any possible actions that can be triggered or any other kind of descriptions. Keep these for state descriptions only. If you need to describe actions, you can use the other descriptions that are available, such as the clickable click label model, semantic property. So talking about switches brings us naturally onto switch accessibility, and in fact, the accessibility aspects for any other kind of toggleable components, such as text boxes, checkboxes, radio buttons, and so on. Any component that can be toggled between different states by the user. So what's up with these when it comes to accessibility? So let's take a look at an example of a switch composable and how this might currently be represented. We have nothing special going on here. We are composing a text label along with a switch composable that could be used to toggle a state value. When it comes to how talkback will represent this composable, we'll see something like the following. So we can see here that the label and switch components are represented as individual elements. So though we're focusing on the label, then we're focusing on the switch, we interact with the switch and vice versa. There's two key issues here. So the user here would hear the label description being described and then nothing else. We are kind of expecting that they would move to the next item to get more context, when we should really provide that context up front. And the second issue here that is only the toggle component is toggleable. So this means that the user will be focused on that label. It will say enable notifications, and then they'll probably think, do I click this? Where do I go now? Do I have to move somewhere to toggle this? And which is what we're implying. Like, we've read you this label, now you need to navigate to the next item to toggle that on or off, which feels a bit weird. And this is actually something that bugs me in applications I use. There's many applications I have which I expect the whole row to be interactable, and it's not. I have to click on the actual switch or the checkbox. So this is actually a thing for all users that is actually quite useful to have. So we can actually build on this composable to improve things for the user by making the row that contains our children the toggleable component. So instead of the switch being toggleable, our parent row becomes toggleable. This means that the parent row holds, manipulates, and communicates the state of the toggleable component, and the user interacts with that row rather than that individual switch component. We can see here now with talkback that the entire row becomes the toggleable component. This not only means that we can now interact with the row as a whole, but it also reduces the number of navigation steps that the user needs to move through. And it also makes it much clearer to the user what that row is doing rather than needing to move between different items. And as I said, this is a much smoother experience for all users rather than just accessibility services. So we can see here from this example that we can simplify the experience for toggle components by lifting the toggle state up into the parent container, simplifying the navigation for our UI. Setting the role semantic is something that is automatically done for switch composables, but when using the toggleable modifier, we have to do this ourselves. So this is used by accessibility services to be aware of what the component is, and then also communicate that to the user. So the role modifier we can see in the code example here, where I've assigned the role as a switch. If you're going to dive into this, you can see the different roles that are available, and you can assign them accordingly. So last but not least, so when it comes to these kind of interactions with components, executing a single action is not a complicated thing to communicate or execute when done via talkback. However, there are some cases in our UI where there may be multiple actions that can be executed, or those actions aren't clearly represented or accessible within the UI. For example, if you have items that need to be swiped to perform certain actions. In these cases, the accessibility APIs provide us with what are known as accessibility actions. So let's take an example. We have a list of items, each represented by a clickable column. Clicking the column launches a screen to read more information about the email. But there is also an icon that can be used to delete the email. We might also have other actions here, maybe another icon that does something else, or a button, or even some actions that require the user to swipe the card to perform an action, which we often see in email apps. With this composable in mind, we can see how talkback behaves. So we can see here that we need to navigate through each of our items in our composable, listening to the description of each one. So we can see there talkback moves on the card, and then it also moves to the delete icon to navigate through. So the user will have to navigate through each of those actions to find out that there's actions available. If we have a long list of emails or we have a lot of actions that are supported, this could get very long and a bit tiresome for users to navigate through. Instead, we can utilize what are known as accessibility actions. This is an API that allows us to provide access to these actions with greatly reduced friction, and is also a native fashion that talkback users will be familiar with. So let's see visually how talkback handles this. So we can see here now that the actions, we're still navigating through, but we can see that the actions are now accessible through the native accessibility actions route, a user experience that talkback users are actually very familiar with. This reduces the number of navigational steps that need to take when navigating through our items, as well as also providing those actions in a way that talkback users are familiar with. And as we could see before, there isn't much code that's needed to add these into your project. So we've seen here that we can provide access to actions using a native API for talkback users. And as well as being aware, it's important not to disregard accessibility for the UI components that trigger these actions. So the things like the delete icon on other components, they still need to be accessible. So we can't just skimp on accessibility when we're using actions. So yeah. Now, this is the last section. I forgot about this one. So on the topic of reducing navigation, there is a feature of talkback that allows users to control how a screen is navigated through using talkback. So one of these ways is via headings. So if a screen has content that is separated by headings, then the screen can be navigated through using these. And this is actually really interesting. I didn't know this was possible in talkback. In your talkback settings, you can control how you want to move through a screen. And headings allows users to skip massive parts of content and just find what they want. So here we have a simple text composable that is displaying some title of a section in our screen. It's likely we have multiple sections that are styled like this. Without the use of headings, we would see something like the following when using talkback. So we can see here that we need to navigate through each focus item via talkback. If our screen had a lot of UI components, and not everything was this simple title paragraph setup, things would get pretty lengthy. If we had images, subheadings, and so on, the user would need to move through a lot of content to find something that they wanted to read, which isn't ideal. However, if we use semantics to mark our composables as headings, then talkback will recognize these composables as headings for sections of our UI. So we can then see this in action. And now we are able to move through our UI by just using the heading. So in my talkback settings, I enabled the heading navigation. And we can see here that now it's much quicker to navigate through the UI, as its talkback is just focusing on the headings and moving through the UI in such a fashion. Again, if we had a much more complicated UI, this would allow our users to move through it seamlessly in a good speed. So we've been able to see that we can use headings to break up our content into smaller navigatable sections, reducing friction for users who have TalkBack enabled. And with the ability to do this, it's important to be aware how you can break up your content in such a way. While we saw this simple example of all text, your UI could look different. So we can be creative about how we break this up and make it simpler for users to navigate through. If your content is not broken up into sections and does not have headings, do not use heading semantics, as you'll likely cause more confusion than the helpfulness that you might think you're providing. And finally, don't use headings for visual decorations. This would again cause confusion and result in the user navigating through the screen and knowing what they are. So at this point, we've covered a lot of concepts around semantics and simplifying navigation through TalkBack. So just want to quickly touch on custom composables in case this is useful for anyone. You are likely going to be building custom composables at some point. Maybe you're not using material APIs and you're building your own composables based off of a design system. These are going to work in pretty much the same way when it comes to semantics and all the accessibility tips and tricks we've learned throughout this talk. We're going to be using the same modifiers, whether if you're making your own switches, checkboxes, you can use the same modifiers to apply the semantic properties that those composable needs. And similarly, if you're doing custom drawing or lower level things on the canvas, you can again get creative and use the semantic properties on click labels to define what the content of that canvas means. So whether you're working with high level composables or making your own custom ones, the semantics will work the same. Just if you're doing lower level stuff and custom things, you probably just need to be more aware of the semantics that you're providing. Cool. So with all that in mind, we now have a good handful of knowledge around making composable accessible. This isn't an extensive collection, but it's enough to help improve our apps for users. As an engineer, I would highly encourage you to try using TalkBack on your device, learn how it works and how your app behaves with it. And once you understand how TalkBack works, it can really open your eyes as to how things will operate when you're building your apps. And this is really helpful for understanding where your app falls short in terms of accessibility, allowing you to create better experiences for all of your users. If you're looking to do some further reading, there's a couple of links here that are really helpful in accessibility. There's the official Google Colab. We have some blog posts on accessibility over on the Compose Academy blog, as well as a couple of blog posts at the bottom there, which are really good resources for learning more about accessibility APIs and also semantics in Jetpack Compose. If you're looking to learn more about Jetpack Compose, maybe you haven't used it too much or you're just getting into it, I'm currently working on a course, book and a course that will be released at the end of this month. If you want to learn more or sign up for the waitlist, please visit this URL and you'll get an email when it's released the last week of November. Cool. That's it. We're done. Just used up most of the time, but I think there's a few minutes for questions. And also you can catch me on Twitter at Hi There Joe if you want to reach out there also. I don't think there's any questions. So yeah, nothing's come through. So that's okay, I guess. But yeah, if there's any questions, oh, there is no questions. Just want to say thanks. Cool, no problem. Glad you enjoyed it.